Good day.
This is Bennett, also known as Jeremiah. Today I'm going to show you the difference between undefined and non-real. I'm also going to show you how to solve for inequalities in fractions. So if you're interested in similar type of videos, the playlist is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. So let's begin. Alright, here is the first question. So you're given this fraction, and the first question says, for which values of x will f at x be unreal? So the first thing you need to know is that there is a difference between unreal and undefined. So what is the difference? Whenever we talk about unreal, we're talking about the square root of a negative. So for instance, the square root of negative 4 does not exist. The square root of negative 100, for instance, you can type the square root of anything that is negative, it will not exist. If we have the square root of 25, we know that it is 5, but it's not only 5, it is plus and minus 5, because if you say minus 5 times minus 5, it will give you positive 25. So the square root of 25 has two answers. It has got 5 as the answer, it also has negative 5 as the answer. However, the square root of negative 25 does not exist. So whenever we've got the square root of negative, we call this non-real. So there is a difference between non-real and undefined, or unreal and non-defined. So we already understand that non-real is the square root of negative. What is undefined? Undefined is anything over 0. So if you've got anything over 0, it becomes undefined. For instance, you can even type in the calculator. If you type maybe 100 over 0, you see that it gives you error because it's undefined. So there's a difference between non-real and undefined. So according to the first question, if they say for which values of x will f at x be unreal or non-real, you have to strictly focus on the portion that has got the square root. So you have to ignore every other thing and only focus on whatever has a square root. So it means whatever is under the square root needs to be negative. So this portion needs to be negative. So we'll take this portion and we'll say it must be less than 0, because this is another way of saying negative. If you check in functions, for example, in the textbook, if you check in the topic functions, you will see that they like telling you that a is greater than 0. They're indirectly telling you that a is positive. They don't like saying it in words. Or if they say a is less than 0, they're indirectly telling you that a is negative. So they like using mathematical language rather than words. So whenever you see this stuff, you read it as a is positive. So this part must be negative. Whenever you see them saying non-real or unreal, it means that this part must be negative. So you take whatever is under the square root, you ignore the whole fraction, you only focus on whatever is under the square root, and you take it and make it less than 0 because we want it to be negative. And let's solve. So this, when you take it to the other side, when you take 2 to the other side, you'll end up having x must be less than negative 2. So it means that if we take any value that is less than negative 2, it will cause the whole thing to be non-real. So that is it. That is the answer. So now let's look at the next question. The next question says, for which values of x will f at x be undefined? Now remember, non-real is the square root of negative, but undefined is anything over 0. Whenever they say undefined, you ignore the whole fraction this time and you focus on the denominator. The denominator must be equals to 0. The denominator must be equals to 0. So you take the denominator and you equate it to 0, because whenever the denominator is 0, the whole thing becomes undefined. So whenever they ask you a question of for which values of x will f at x be undefined, you ignore the whole fraction and only take the denominator. You have to solve where it will be equals to 0. So let's solve. You can see that everything is divisible by 3, so we can just divide by 3. If you divide by 3, divide by 3, divide by 3, we'll end up having, so this will end up being 1 minus x squared is equals to 0. If you want, you can just simply take x to the other side, and then you can make it positive because of taking it to the other side of the equation. And then when you square root both sides, you'll have two answers. Your answer will be plus or minus 1, right? So that will be x. So it means x is 1 or negative 1. And another way to solve it is that because it's the difference of two squares, notice that this is the difference of two squares. Why is it the difference of two squares? Difference means minus, right? we have a subtraction sign, and it is a square and a square, right? So it's a square minusing a square, so it's the difference of two squares. So we can solve it by opening two brackets, and then the square root of 1 is 1 and 1, right? And then the square root of x squared is just x, so we'll have x and x. So on one of them is just plus, on the other one is a minus. Then this is equals to 0. Now notice that this is gonna be x is equals to -1, or if you want, you can just simply say, if you want, you can just say 1 is equals to minus x, and then you can say, or 1 is equals to x, right? And then for this portion, when you solve, when you divide both sides by -1, you end up having -1 is equals to x. So there we have it. X must be equals to either 1 or -1. Whenever it's equals to 1 or -1, it will cause the whole thing to be undefined because the denominator will be equals to 0. So that is how it is. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. Alright, finally let's talk about this question. So I'm going to show you 2 questions of this stuff just to make sure that you understand it. So they said for which values of x will f at x be greater than 0. So let me just rewrite this. So now we've got the square root of x plus 2, and we have it as over 3 minus 3x squared. So we're told that it must be greater or equals to 0. So whenever you have this type of question, the first thing you must do is whatever is not factorized, you must make sure it's factorized. So this part, there is no way of factorizing. It's already in this form. And then what about this? We have to factorize. All right, let's factorize this portion. So we have 3 minus 3x squared. If you factorize it, notice that the common factor is 3. So we'll end up having 1 minus x squared. So this part is factorizable further. Notice that if you factorize it, this is actually the difference of two squares because we've got a square minus a square. We're going to have to open two brackets, and then now the square root of 1 is just 1, the square root of x squared is just x, and then we're going to have 1 and x also here, and then on one of them we have a plus, on the other one we have a minus. So this is factorized, so it's factorized fully. So it means we can therefore write this portion here. So we're going to have 3, then we're going to have, so we're going to have 1 minus x, and we're going to have 1 plus x. The order of the brackets does not matter, so this is what we have. So now we want this to be greater than 0. So trust me, this is very easy. All you have to do is, the first thing is that you have to factorize. Once that's factorized, you look for critical values. So critical values, you have to check each portion. What can make each of them 0? So let's check this one first. What can make this 0? So if we say x plus 2 must be equals to 0, we take 2 to the other side, we'll have x as minus 2. So our first critical value is minus 2. So we have minus 2. And then let's check this part. What will make this 0? So 1 minus x must be equals to 0. So if we take x to the other side, you'll have 1 is equals to x. So our second critical value is 1. So we have 1. And then what will make this part 0? It's obvious that it's going to be minus 1. But let's just say we didn't know. But at times, these things can be read straightforward. So we're going to, when you take 1 to the other side, we have x as minus 1. So minus 1 is the third critical value. So we have minus 1. So once we have this, we have to put them in order in the number line. So we'll put this in the number line. So we see that minus 2 is the smallest. So we're going to say minus 2. Then we're going to say minus 1. Then we're going to say 1. All right. So now before we do anything, whenever there is a square root, there is a special thing we do before we do whatever we are going to do next. So what is special is that whenever there is a square root, what is under the square root is not allowed to be negative. So notice that this critical value belongs to this square root portion, because the other ones come from the denominator. So whenever you see the square root, the first thing you need to locate is the critical value that belongs to that portion. When you find it, you'll just simply say not applicable on the group that is less than. So we have group 1, group 2, group 3, group 4. So if this is the critical value that belongs to the square root, the group that is on the left side of the critical value will be not applicable. I'll explain why. So you'll say not applicable. Let me show you an example. Let's say we had this stuff. Let's just say we had x minus 5. So let's say we had x minus 5, and let's just say here it was x plus 2, and we had x minus 2. So if we had a number line, and let's just say we had, so the critical value of this portion would have been minus 2, the critical value of this portion would have been 2, the critical value of this portion would be 5. So which critical value belongs to the square root? It's actually this critical value. So whatever is on the left side of it is not applicable, meaning that in group 1 it's not applicable, in group 2 it's not applicable, in group 3 it's not applicable. So that's the first thing you must memorize. Always look at the square root first, and whatever is on the left side of the square root is not applicable. The reason why it's not applicable is because if I pick anything that is less than 5, for instance, if I pick 2, if I substitute 2 here, notice what will happen. It's going to be 2 minus 5, and then 2 minus 5 is negative 3. So notice that this is the square root of a negative. So the reason why we're saying not applicable on whatever is on the left side of the critical value is because if we substitute it, it will be the square root of negative as a result, and it will be non-real. So this is why we're saying that whatever is on the left side of the critical value is not applicable. Alright, one last example before we move on. This critical value is actually negative 2, this one is actually positive 5, and then this one is actually negative 3. The critical value that belongs to the square root is actually this portion. So it means whatever is on the left side of this critical value is not applicable. So it means this group will not work, and this group will not work. So moving back to this stuff, whatever is on the left side of the critical value, because this critical value belongs to the square root, whatever is on the left side of it is not applicable. So we would say it's not applicable. So only one group is on the left side of negative 2. So that's the very first thing we should do before we even solve. So once that is sorted, we can now solve. So in order to solve this question, they want this stuff to be positive, right? Because it's greater than 0. So we want it to be positive. Now what you'll do is that you'll test any number on the number line, of course except this portion. You should test anything on the number line except the critical values. We can take any number and substitute it here and find out whether it will be positive or negative. My advice is to test 0 because 0 is the easiest number to test. We don't need a calculator in order to test 0. So in the numerator, when you substitute 0, if we put 0 in place of x, we're going to end up having the square root of 0 plus 2. And then our answer will end up being the square root of 2 as the numerator. So at the denominator, if we substitute 0 here, our answer here is literally going to be 1 because 1 minus 0 is 1. And then on this bracket, we're going to have 1 plus 0, which will still be 1. So we're going to have 3 into 1 into 1, right? That would be the result of the bracket. And the answer here is just 3. So it simply means our answer is square root of 2 over 3. So all we wanted to do was to see whether it was going to give us a positive answer or a negative answer. So whatever number we choose to test, you must make sure you know which group is it in. So I chose to test 0, and 0 is in group 3, right? Because it's between -1 and 1. So whatever number you test, make sure you know the group that it is in. So 0 is in this group. So we want to find out whether this group is going to be positive or negative. So 0 is in the third group. I want to find out whether the third group is going to be positive or negative. So if I substitute 0 here, I'm going to end up having the square root of 0 plus 2. And then this is just going to be the square root of 2. So it means at the numerator, I'll get the square root of 2. And then what about at the denominator? So if I say 1 minus 0, it's going to be 1. So this portion is going to be 1. So I'll have 3 times 1. And then this portion is going to be 1 plus 0, which is the same as 1. So this is going to be 1. So it means that this is going to give us 3, because 3 times 1 is 3. So this is going to be 3. So all we wanted to do was to find out whether it was positive or negative. So this is positive. You can take any value you want and substitute it in the calculator to find out. Make sure you just know which group is it in. So this gives me a positive, so it means that this group is positive. Do we have to test every group? We don't have to test every group. Once you know the sign of one group, you know the sign of every group. What do I mean? If this one is positive, the minute we move to another group is going to be negative. And then also here, this is positive, so it means the next group will be negative. So every time I move to the next group, I change the sign. So if there was another group, let's just say there was another group, let's just say we had other groups as well here. If this is negative, when I move to the next one, it's positive. And then when I move to the next one, it's negative again. So every time we move to a different group, the signs change. So that's how it is. We don't have to test everywhere. So that is it. According to the question, we want the answer to be positive. And which group is positive? Group 1 does not apply, group 2, group 3, and group 4. So group 3 is the one that works, right? Group 3 is the one that gives us positive. So let's describe group 3. So notice that group 3 has a beginning and an end. Whenever it has a beginning and an end, you put x between. So you'll say it's between -1 and 1. And the inequality signs will always face like this. It will never face the other way whenever x is between. So you'll write it like this. What about if group 1 worked? If group 1 worked, notice that group 1 has got no beginning, but it has got an end. So notice that this arrow points to the left. It means that it can become as small as possible. So what you'll do is that you'll just simply say x must be less than -2. That was if group 1 worked. What about if group 4 worked? If group 4 worked, notice that there is a beginning but there is no end. So it means that it can become as large as possible. Notice that the arrow points to the right. So what you'll do is that you'll simply say x must be greater than 1. So that's what you'll be doing. So whenever you're describing the beginning group, you just simply say x is smaller than this critical value. Whenever you're describing the last group, you'll simply say x must be larger than this critical value. But for now, it was only group 3 that worked. So this is the answer. Now let's focus on this part. If the question says greater than only, you would leave it like this. But if the question says greater or equals to, then you would put equal signs as well. The only thing you must be careful of is that if these critical values belong to the denominator, we are not allowed to put equal signs even though the question says equal, because the denominator is not allowed to be 0. If the denominator is 0, it causes the whole thing to be undefined. So because these two critical values belong to the denominator, we are not allowed to put equals to even though the question says equals to. So let me show you another example just to solidify the understanding. Alright, here is another question. Just before I attempt this question, if you are interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details just in case these ones have changed is found at the end of this video. Alright, here is another example. Remember, the first step is to make sure everything is vectorized. So let's look at the numerator. We have a quadratic equation, so we know we have to open two brackets. So we're going to have x, and then it's going to be 3 and 2. And the sign of the middle number goes to the bigger number. And then what does -3 have to multiply by to give you -6? It has to multiply by a +2. So the top is factorized. Now let's talk about the denominator. So this can be factorized in 2 stages. So notice that we have, first of all, the common factor is 2. So we have 2 as the common factor. If we factorize 2, we'll be left with 1 minus 4x squared. So then this becomes the difference of two squares. So this is a square and this is also a square, so we've got two squares subtracting. So when we factorize this portion, we have to put two brackets because it's a difference of two squares. So the square root of 1 is 1, the square root of 4x squared is 2x. And then we're going to have 1 and 2x. So now notice in one there is a plus, in the other one there is a minus. So this is the factorized portion. It means that we're going to say 2, then we're going to say 1 plus 2x, and then we're going to say 1 minus 2x. So this must be less or equals to 0. So that's what we have. So the reason why we're factorizing everything is that we want to make sure we're able to see the critical values of everything. So we're going to have 4 critical values simply because there are 4 brackets. So we can easily see that what will make this 0 is positive 3, right? Just by changing the sign. Or if you want, you can solve for it. You can just solve for where it's equals to 0. And when we take 3 to the other side, our answer will be the same. So for this portion, the critical value will be negative 2. And for this portion, if we solve, we're going to have 1 plus 2x. We can also see it. We know it's going to be negative half, but let's just solve it. So we'll take 1 to the other side, and that's what we'll have. So we'll have x is equals to negative half. And then for this portion, we know it's going to be positive half. But if you want, we can solve it. And then when we take these to the other side of the equation, we'll end up having 2x. And when we divide both sides by 2, we'll end up having half is equals to x. So we'll have minus half and we'll have half. So we have to draw a number line. So let's draw a number line. So if we have a number line over here, we have 4 values. So the smallest value is negative 2. So we'll have negative 2, and then the second smallest one is negative half, and then followed by half, then followed by 3. So how many groups do we have? We have got 5 groups. So we've got group 1, group 2, group 3, group 4, and finally group 5. So let's test one group. The easiest number, because we don't see 0 here as the critical value, so the easiest number to test is 0. So if there was an x, 0 would have been one of the critical values. So whenever x is standing alone, it would have been one of the critical values, whether it is at the numerator or at the denominator. So for instance, if this 2 was actually 2x, then we would have had 0 as one of the critical values. So just be careful of that. So since 0 is not one of the critical values, let's proceed. So if we substitute 0 here, this part is going to end up giving us negative 3. This part is going to end up giving us 2. And then this part we're going to end up having 1, literally, because this will disappear. And this will also be 1. So basically in the numerator, we have our answer as negative 3 times 2. The numerator gives us negative 6. And then what about the denominator? We're going to have 2 times 1 times 1. So this is going to be 2. So our answer is negative 3. So even before we divide it, we can already see that the answer will be negative. So we have negative. So where is 0? 0 is actually between negative half and half, right? 0 is in this group, in group 3. So this part is negative, meaning that this part will be positive, negative, right? Every time you jump to a different group, just change the sign. So it is easy, we've solved it. So let's see which critical values belong to the denominator. So the critical values that belong to the denominator are these two. So we have to make sure, we have to be careful that they don't have equal signs. So I'm just going to mark them just to remind me, right? Both of them belong to the denominator. So let's proceed. We want our answer to be negative. So which group gives us negative? So the group that gives us negative is group 1, group 3, and group 5. So group 1, notice that the arrow points to the left. We have no beginning, so x is simply less than negative 2. And the question says less or equals to. So it means we have to put equals to as well. So we are allowed to put equals to here because it is not this critical value. Now let's describe group 3. It has a beginning and an end. So we're going to put x between. So we're going to have negative half and we're going to have half. And then the inequality signs will face this way. Well, we're not allowed to put inequality signs because we have marked them. They belong to the denominator. And then finally, let's describe group 5. So group 5 has a beginning but no end, meaning that it can become as large as possible. So whenever it has got no end, you will say greater, so greater than 3, and it is allowed to have the equal sign. So there we have it, we have solved it. If the question only had less than, then it means you don't even have to worry about equal signs everywhere. We'll just not think about that, we'll not include it. And there we have it. Alright, we have reached the end of this video. I've included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.